Welcome back to the channel. Today we're taking a look at Kode Dot, an open-source handheld device aimed at makers, hackers, and electronics enthusiasts. It's designed to consolidate the typical maker workspace into a single portable unit, combining a microcontroller, display, sensors, and connectivity into one compact package. Let's break down what this device offers and who it's really for. At its core, Kode Dot is built around the ESP32 S3 dual-core microcontroller, which is a capable chip commonly used in EOT and embedded projects. It comes with 32 megabytes of octal flash and 8 megabytes of octal PSRAM, which should be sufficient for most prototyping and experimental work. There's also a microSD card slot for expandable storage, useful if you're logging data or carrying multiple project files. The display is a 13-inch color AMOLED touchscreen with a resolution of 502 by 410 pixels. For a device this size, that's a sharp and vibrant screen, and it's touch-enabled, which opens up possibilities for creating interactive user interfaces directly on the device. Whether you're visualizing sensor data or building menu-driven apps, the display should handle it well. On the sensor side, Kode Dot includes a 9-axis IMU, which means you get a 3-axis accelerometer, gyroscope, and magnetometer all in one. This enables motion detection, orientation tracking, and gesture recognition. There's also a real-time clock for time, stamping events, and a battery fuel gauge to monitor power levels accurately. These are practical additions that give the device a more polished, standalone feel compared to bare development boards. Audio capabilities are handled by an ICS 43434 MEMS microphone and a 1-watt speaker driven by a MAX 98357A amplifier. That means you can build projects that listen and respond, whether that's voice commands, sound-reactive visuals, or simple audio playback. The speaker won't blow you away, but it's functional for prototyping and demos. Powering all of this is a 500 mAh power lithium polymer battery, rechargeable via USB-C. For a portable device, this is a modest capacity. You'll get enough runtime for testing and on-the-go demos, but if you're running power-intensive projects continuously, you'll want to keep a charger handy. The device uses a BQ25896 power management IC, which is a solid choice for efficient charging and power distribution. Connectivity is where Kode Dot tries to stand out. You get Wi-Fi on the 2.4 GHz band, Bluetooth Low Energy, and ESP32 for direct peer-to-peer communication between ESP32 devices. There's also a GPIO header with access to IC, SPI, UART, and 12 general-purpose I/O pins, plus 5-volt and 3-volt power outputs at 2 amps each. That's more than enough to connect external sensors, motors, LEDs, and other peripherals. On the back, there's a magnetic connector for snap-on accessories or charging via a magnetic base, which is a nice quality-of-life feature. One of the more interesting aspects of Kode Dot is its operating system, kodeOS. Instead of reflashing the device every time you want to run a different project, you upload your code once, and it becomes an app that you can launch from the home screen. You can name it, give it an icon, and switch between multiple projects without reconnecting to a computer. This app launcher approach is a departure from typical microcontroller workflows and could be genuinely convenient if you're juggling multiple ideas or showing demos to others. Programming is done using familiar environments like Arduino IDE, Platform I/O, or ESP32. You upload code over USB-C, and once it's on the device, it behaves like a standalone application. This is a user-friendly touch that lowers the barrier between coding and actually using what you've built. Now, let's talk about the stretch goal features. The campaign includes unlockable add-ons that get integrated into all units at no extra cost once funding milestones are reached. At $100,000, you get IR transmit and receive, which lets you interact with TV, air conditioners, and other infrared-controlled devices. At $250,000, NFC and RFID support is added, covering both low-frequency 125 kHz RFID and high-frequency NFC. This would allow you to read, emulate, and interact with access cards and contactless systems. At $500,000, a vibration motor is included for haptic feedback. These are genuinely useful features, but whether they get unlocked depends entirely on the campaign's success. So keep that in mind if any of these are must-haves for your use case. There's also an optional hacking module that connects to the top of the device and adds an ESP32C5 for dual-band Wi-Fi on 2, 4 and 5 GHz, a sub-GHz radio for analyzing and replaying classic RF signals, and an NRF24 radio for experimenting with proprietary 2, 4 GHz protocols. This module is aimed at more advanced users interested in wireless security research, signal analysis, or retro RF experimentation. If that's your thing, it's a solid expansion, but it's an add-on, not part of the base device. There's also a special transparent edition being offered exclusively during the Kickstarter campaign. It features a see-through enclosure that shows off the internal components and PCB layout. According to the campaign, each transparent unit goes through extra quality control to ensure everything looks clean and aligned. It's a collector's item aimed at early backers and won't be available after the campaign ends. Physically, Kode Dot measures 73 by 43 by 15 millimeters and weighs about 50 grams. That's roughly the size of a small handheld gaming device or a chunky garage door opener. It's definitely pocket-friendly and light enough to carry around without thinking about it. Form factor also includes a 4-button directional pad, plus boot, reset, select, and back buttons, and a WS2812B addressable RGB LED for status indication or visual effects. So, who is this device actually for? Kode Dot is clearly targeted at hobbyists, students, and makers who want to prototype quickly without dealing with breadboards, jumper wires, and fragmented setups. If you're the kind of person who sketches ideas on the go, likes to demo projects at meetups, or just wants a cleaner workflow, this could be a valuable tool. It's also appealing if you're teaching or learning embedded systems, since everything is already wired up and ready to code. That said, this isn't a replacement for traditional development boards in every scenario. If your project requires a ton of GPIOs, high processing power, or extensive peripheral support, you're still better off with a Raspberry Pi, a full-featured ESP32 dev board, or even a custom PCB. Kode Dot is more about convenience and portability than raw capability. It's a tool for rapid prototyping and experimenting, not necessarily for deploying final, production-grade devices. One thing worth noting is that the unlockable features are contingent on funding goals. If the campaign doesn't hit those milestones, you won't get IR, NFC, or the vibration motor, and that could affect the overall value proposition depending on what you were hoping to build. The base device is still functional and versatile, but those extras would definitely expand its usefulness. Another consideration is the ecosystem. Since kodeOS and the app-based workflow are custom to this device, you're relying on the community and the developers behind Kode Dot to keep things updated and supported. Open source is great for transparency and collaboration, but it also means longevity depends on community engagement and ongoing development. If the project gains traction, that could lead to a healthy library of apps, tutorials, and accessories. If it doesn't, you might find yourself on your own more than you'd like. In terms of value, Kode Dot is positioned as an all-in-one convenience package. You're paying for integration, portability, and a streamlined workflow, not just raw specs. For makers who value speed and simplicity over tweaking every detail, that trade-off makes sense. For those who prefer maximum control and customization, the traditional route of separate modules and dev boards might still feel more flexible. Overall, Kode Dot is a thoughtfully designed tool that addresses real pain points in the maker workflow. The combination of an AMOLED touchscreen, built-in sensors, battery, storage, and an app-based OS is genuinely compelling for anyone tired of messy setups and constant reflashing. The stretch goal features add meaningful functionality if they're unlocked. And the optional hacking module opens up some interesting possibilities for security research and RF experimentation. Is it perfect? No, the battery capacity is modest, the unlockable features aren't guaranteed, and the ecosystem is still in its early stages. But for the right user, someone who values portability, ease of use, and rapid iteration, Kode Dot could be a genuinely useful addition to the toolbox. If you're a maker looking to simplify your workflow and carry your lab in your pocket, this is definitely worth considering. That's Kode Dot. Let me know in the comments if you're planning to back this project, or if you have questions about how it compares to other maker devices. Thanks for watching, and I'll see you in the next one.